Geometric sequence and geometric means. A geometric sequence is a sequence in which every term after the first is the product of the preceding term and the mixed number called the common ratio of the sequence. We will use the following notations for geometric sequence. A sub 1 is equal for the first term. A sub n is equal for the nth term. R is for the common ratio. N is equal for the number of term from a sub 1 to a sub n. So, S sub n is equal for the sum of the first n term. Geometric sequence. Consider the geometric sequence 2, 6, 18, 54, 162, and so on, in which each term after the first can be found by multiplying the preceding term by 3. That is, the second term, the first, is equal to the first term times 3. The third term is equal to the second term times 3, and so forth. A sequence like this is given a special name. For example, the geometric sequence 1, 1/2, 1/4, 1/8, 1/16, and so on, where a sub 1 is equal to 1 and the ratio is equal to 1/2. To obtain its succeeding term, multiply the preceding one by 1/2. Thus, a sub 2 is equal to a sub 1 times r is equal to 1 times 1/2 is equal to 1/2. A sub 3 is equal to a sub 2 times r is equal to 1/2 times 1/2 is equal to 1/4. A sub 4 is equal to a sub 3 times the common ratio is equal to 1/4 times 1/2 is equal to 1/8. A sub 5 is equal to a sub 4 times r is equal to 1/8 times 1/2 is equal to 1/16, and so on. Notice that if we divide any term by the preceding one, the quotient of or ratio is always 1/2. This is why we call R as the common ratio of the sequence. The formula for the nth term. As with arithmetic sequences, there is a formula for calculating the nth term of a geometric sequence. Let us calculate several terms of an arbitrary geometric sequence. First term is equal to a sub 1 a sub 1 is equal to a sub 1 times r to the power of 0. Second term is equal to a sub 2 is equal to a sub 1 r to the power of 1. Third term is equal to a sub 3 is equal to a sub 1 times r to the power of 2. Fourth term is equal to a sub 4 is equal to a sub 1 times r to the power of 3, and fifth term is equal to a sub 5 is equal to a sub 1 to the times r to the power of 4. Thus, we have nth term is equal to a sub n is equal to a sub 1 times ratio to the power of n minus 1. Sample problem. First, find the 7th and 10th term of the following arithmetic sequence. Geometric rather. The given is 9, 3, 1, 1/3, 1, 9, and so on. Answer is a sub 1 is equal to 9 and the ratio is 1/3. A sub n is equal to a sub 1 times r to the power of n minus 1. So the a sub 7 is equal to 9 times the value of r, 1/3, and the value of n is 7 minus 1, so is equal to 9 times 1/3 to the power of 6 is equal to 1/81. And a sub 10 is equal to 9 times 1/3 to the power of 10 minus 1 is equal to 9 1/3 to the power of 9 is equal to 1/2187. Therefore, 1 over 81 and 1 over 2187 are the 7th and 10th, 9th term of the sequence respectively. The sum of the first nth term. We know to derive a formula for calculating the sum of the first nth term of a geometric sequence. Let S sub n denote the sum of the first n terms. The series is S sub n is equal to a sub 1 plus a sub 1 times the ratio plus a sub 1 times the ratio to the power of 2 plus a sub 1 times the ratio to the power of 3 plus so on plus a sub 1 times ratio to the power of n minus 2 plus a sub 1 to the times the ratio to the power of n minus 1 and so now multiply the equations by r. We have r sub rs sub n is equal to a sub 1 r plus a sub 1 r to the power of 2 plus a sub 1 r to the power of 3 plus so on plus a sub 1 to the times r to the power of n minus 2 plus a sub 1 times r to the power of n minus 1 plus a sub 1 times r to the power of n is in the equation of this will be the equation number 2. Subtracting equation number 1 and equation number 2 and solving for s sub n, we have s sub n is equal to a sub 1 minus a sub 1 times r to the power of n over 1 minus r, or s sub n is equal to a sub 1 times 1 minus r to the power of n over 1 minus r. So sample problem. Find the nth term and the sum of the first 8th term of the geometric sequence -2, 1, -1/2, 1/4, and so on. The answer is a sub 1 is equal to -2 and the ratio is equal to -1/2. A sub n is equal to a sub 1 times ratio to the power of n minus 1. So a sub 8 is equal to -2 times 1/2 over 2 to the power of 8 minus 1 is equal to -2 times 1 times -1/2 to the power of 7 is equal to 1 over 64. So s sub n is equal to a sub 1 minus a sub 1 times r to the power of n over 1 minus r is s sub 8 is equal to -2 minus -2 times 1 -1 over 2 to the power of 8 over 1 minus -1 over 2 is equal to -85 over 64. Therefore, 1 over 64 and -85 over 64 are the 8th term and the sum of the first 8 terms respectively. So, geometric means the term between a sub 1 and a sub n of a geometric sequence are called geometric means of a sub 1 and a sub n. If the geometric sequence are a sub 1 to a sub 5, then the geometric means are a sub 2, a sub 3, and a sub 4. Sample problem. Insert 4 geometric means between 5 and -160. Answer is, since we must insert 4 numbers between 5 and -160, there are 6 numbers in the sequence. This means that a sub 1 is equal to 5 and a sub 6 is equal to 160, and we must find a sub 2, a sub 3, a sub 4, and a sub 5. So the formula is a sub n is equal to a sub 1 times ratio to the power of n minus 1. So negative 160 is equal to 5. The value of a sub 1 is 5 and the ratio here is the value of a sub 1 is 5 times ratio to the power of 6 minus 1. So is equal to negative 160 is equal to 5 times ratio to the power of 5. So the ratio is the ratio is 2. So a sub 2 is equal to a sub 1 times r minus is equal to 5 times negative 2 is equal to negative 10. A sub 3 is equal to a sub 2 times ratio is equal to negative 10 times 2 times negative 2 is equal to 20. A sub 4 is equal to a sub 3 times ratio is equal to 20 times negative 2 is equal to negative 40. A sub 5 is equal to a sub 4 times ratio is equal to negative 40 times negative 2 is equal to 80. Thus, the four geometric means between 5 and negative 60 are negative 10, 20, negative 40, and 80. Sample number 2. Find a sub 1 and r for a geometric sequence that has a sub 2 is equal to 10 and a sub 5 is equal to 80. The answer is 80 is equal to a sub 5 is equal to a sub 1 times ratio to the power of 5 minus 1. So 10 is equal to a sub 2 is equal to a sub 1 times ratio to the power of 2 minus 1. So 80 divided by 10 is equal to a sub 5 minus a sub 5 over a sub 2 is equal to a sub 1 times ratio to the power of 2 over a sub 1 times ratio to the power of 1. So 80 divided by 10 is equal to ratio to the power of 3. So ratio to the power of 3 is equal to 8. Ratio to the power, and the ratio is 2. Then 10 is equal to a sub 2 is equal to a sub 1 ratio. Therefore, 5 and 2 are a sub 1 and r respectively. So that would be all. Thank you.